Hello and welcome. Thank you, Eric, for inviting me. My name is John Tkaczewski. I'm the co-founder and president of File Catalyst. So we specialize in moving big, heavy data or moving large, big data. And Eric thought, and so did I, that talking about data gravity would be a very appropriate topic for this conference. So I'm going to first give you a quick introduction what data gravity is. We did not come up with this concept. It was Dave McCrory, probably around 2010, that coined this that coined this phrase. And the concept is fairly simple. It says that really, in essence, the data is difficult to move around. And because data is very difficult to move around, everything else will kind of follow wherever the data is sitting. So your application, your services, and any other tools will follow that idea. So if you ever sat down on a trampoline while the kids were jumping around on it, what would happen to the kids? They would kind of just fall on you. The same idea applies here, is that the data is heavy and everything kind of just falls onto the data and wants to be near the data. But besides of just saying that data is heavy, there's some other concepts that try to go a little bit deeper why the data is stuck. And the main two factors, so this is the theory of data gravity, is that you got the latency and throughput. The further away you are from the data and the less bandwidth you have, the more attracted you are to be closer to the data, to be sitting very close to it, to have access to it, to have a quick access to the information. And the data could be, it could be large video files, big data. It could be almost anything, anything that requires a lot of storage. So as, other services are moving closer and closer, they have less latency, better throughput to the data, and then therefore they can offer more efficient services. So what would happen is that if data is so heavy to move around, there are forces that if data is sitting, if everything wants to move so close to the data, how come we're not sitting in one big giant blob? That means we're not sitting, let's say, in the cloud, all of us. Well, first of all, we don't live in a cloud, but there are, forces that push away and for some data to be, let's say, copied to a different location. Or there are forces that, for business needs, require you to, be further away from the data. So the forces that keep us away is really your privacy issues, your security. Cost is probably one of the big factors as well, and the features and convenience. So once again, users don't live in a cloud. Cloud is on its own. It's a big data center. Nobody lives in there. So all these ideas kind of follow that. That's what pushes a lot of vendors not to have everything stored in one big giant blob because of all these issues that come up. So think of it as a sort of like a gravitational. If you think of forces that keep the planets away from crashing with each other, and think of the gravity that tries to pull the planets together, so there's a fine balance between what's happening with the data as well. That's why we don't end up having everything in one single location, and this fine balance is the best scenario I could describe it is here. I'm going to try to compare two very different entities, but both of them actually have a very similar idea: store data. So I'll take my USB thumb drive, which I have in my pocket, and I'll compare it to Amazon S3. Why? They both have forces that draw me towards it, but also, have some problems with it. So look at my USB stick. It has convenience. It's in my pocket, easy to use. I can move it. I can access data really fast. It's instantaneous. I plug it in and I have the data there. S3, well, it gives me much more storage, flexible, unlimited storage. It gives me the ability to share with the world what's with my data. And of course, there's a built-in security, which my thumb drive probably doesn't have. If anybody gets hold of my thumb drive, well, you have all my data. So imagine these two forces. There's positive forces that attract me to both of these for different reasons. And there's a place for both of them in the world today. And it's really the concept is that all of this is kind of just balancing out this concept. So you're going to have your personal storage, you're going to have an office storage somewhere, there's going to be cloud providers out there, and there's if you see the big planet, there's other cloud providers out there as well. So everything is kind of living in a balanced state. Of course, this is real world and it's computing. Things change very quickly. So if you think about, in a matter of years or even months, this balance is changing. So you can think, cloud providers are growing. My personal storage is probably staying the same, and local office storage is changing as well. So it's a dynamic model, but there is a balance at any given time. So how data gravity applies to the cloud, and here's some concepts that come from really datagravity.org. That's the website that kind of talks about this, and I'm sure there's actually going to be some PhD thesis eventually written about this. But the idea is easy: make the inbound data to the cloud as light as possible. So you want to get people into the cloud and to store their data. You want to make it easy. That's why a lot of cloud vendors, for example, will not charge anything in to bring in data in, but then if you want to take data out, then you have to pay for it. So what happens? They just increase the gravity of the data sitting on their cloud. And another example, which is I think really brilliant, is the contextual information. So here's this was example on Flickr, but it could be done with YouTube or any other cloud vendor out there. So let's say I take my picture I posted on Flickr, and if I now decide that I want to pull this data out from that cloud vendor, so what's going to happen? First of all, if I can, because very often I'm not allowed to take anything away once I post it somewhere, but if I take it, I'm going to lose quality. I'm not going to, I uploaded maybe an 8 megapixel picture, but now I'm taking away maybe a 2 megapixel picture because it was, it was rendered smaller on the cloud. But the biggest thing I'm losing if I pull this picture away from Flickr is the comments. Imagine somebody commented on it. I'm losing all the likes. I'm losing all the other suggestions that the Flickr engine can say. Oh, you photographed this location, therefore you should take a look at these similar pictures. So all of this is gone. So once again, this makes the data heavier once it reaches the cloud, besides of the cost and the contextual stuff. So these are the concepts that kind of the data gravity theory is working with. So the concept here is really they want to come up with a more solid computational theory on this. So you can actually define real rules, and you can then have real life examples, apply this to real, but right now this is still fairly theoretical stuff. It borrows a lot from the gravitational theory, as I mentioned, planets staying in balance. It has a lot of similarities how nations how nations negotiate trade tariffs. So for example, you got the NAFTA agreement in North America, and then all other smaller nations want to be part of the party, but they have to connect individually. Same thing with European Union being another big trade agreement, and then everything wants to kind of gravitate towards those big agreements. There's the idea of the Shannon's law, where how much data can be squeezed down the wire, because we're talking about the latency and throughput, and the classic von Neumann bottleneck. That once again, how to get the data as fast as possible from the persistent storage to the CPU. And the idea involves, caching, involves minimizing the data, and so forth. So this is really the in essence the theory of data gravity. But one thing that I'm a accelerated file transfer vendor, I just wanted to put in my 2 cents how all of this applies to what we do at File Catalyst, and how we fit in all of this entire theory. So I just want to go quickly over some basics, how traditional file transfers work, because you really have to start looking at the data transfer and file transfers to understand why data is so heavy once it's arrived somewhere. So all the existing protocols, FTP, SFTP, HTTP, all rely on TCP. And without TCP, internet wouldn't exist today. It provides, the reliability. When you request actually a file, you get the actual file and you get the right data. It has the congestion control built in. Without TCP, everybody would be screaming really loud on the internet, and no one would ever get anything. So TCP keeps everyone quiet enough so everything can get through the line. So TCP has been around a very long time, but the problem with TCP is that when you start to look at a transmission of big data, TCP has a very serial process. And as it was mentioned earlier, that TCP is very chatty. So with TCP, you're going to send a packet of data and wait for that acknowledgement. So when it arrives, once I get the acknowledgement, then I'm going to send the next packet of data and wait for the acknowledgement again. The positive acknowledgements, what's happening is that there's a lot of talking going on and not a lot of sending, because as the latency grows between the two points, everything slows down. So the faster the network, the further the 2 points, TCP is going to get slower and slower. So it's not an ideal solution. So what we do with our acceleration, with file transfer acceleration in File Catalyst, is that we actually use UDP for transferring the files. We move data at full speed, and all those smarts that has TCP built in, we actually built this into our own applications. So this will give you, almost a perfect clean rate. It's not going to be jagged, like going. Speeds are not going to be slowing down or going all over the place. You're going to get a full line speed, and you're going to get a clean line for your transfers, and we're not going to be affected by that latency. So because the data now is flowing non-stop, so we always multiple packets of data go at the same time, and we only wait for the negative, for errors. So we only acknowledge the exceptions. So as you're sending the data, as you're sending the data and you see that, let's say, one of the packets, you drop one of the packets, we just retransmit that. So it's really the concept is, send as much data as possible on your line, so your line is always busy. Okay, we're back. So that's the idea. So going back to my gravity model, what's happening with the gravity? Well, we cannot. We're not ISPs or internet service providers. We cannot make your throughput any better. So we cannot speed up your line. We're going to still work within the parameters of whatever your connectivity is. But the other aspect, latency, now disappears. So in a sense, what's happening with the data gravity is that it still exists, but it's reduced, and gives you ability to be more flexible where the data, where you move your data and how you move it. So with the model we have, it's that we still have gravity. It didn't change because we're still kind of limited by the throughput that you have, but we are not. It's definitely faster because now you're immune to the latency side of things. So you can be further away from the data and still get good access to it and good speed. the gravity towards every storage location still exists. Even with my going back to my example of AWS versus a USB thumb drive, both of them have gravitational forces, and with acceleration, well, it definitely helps AWS now because you can move data faster to AWS, but there will be still gravitational forces that will take you to the local storage. But ultimately, as the owner of the data, now you have more choices. And sort of this is the concept that you're going to have here, is that now you have your data, you can put it wherever you want. You can move your data around where you need it to be. It's faster. It's probably not, it's still not ideal, but it gives you a much better flexibility of what to do with your data and where you want it to go. So it reduces the whole gravity aspects of it. The other aspect of acceleration where it helps out is, I thought it's where at YouTube Studios here, I would be very proper to talk about data center allocation. So here's, this is sort of the Google data centers around the world today. So you can see one of the biggest computing companies where their data center allocations are. And you can see that there's still quite a few empty spots where there's nothing. Why is there nothing? It's probably, economics. It's probably not worth building a data center in those locations. But what ultimately means is that getting to those users that are further away from the cloud facilities or the data center facilities, the file transfer acceleration becomes a very useful tool to get to those users without investing in data centers. And think of this. This is Google. It's one of the largest computing companies in the world. But think of the other players that also need computing power around the world, where they can be and where they can invest. So of course, as the scale drops, the number of data centers exponentially probably drops as well. So this gives you the idea of what happens to those users. So once again, because of the data gravity is now reduced and you can kind of accelerate the content to anywhere you want, you're not as dependent of having all these drops or data centers around the world. So with the idea of that reaching, if you can reach those users all around the world without building a cloud, well, what's in the future? So I mean, I'm not a wizard. I can't tell you what's going to be in the future. I can just see where we are right now, and from the perspective of the data gravity theories and our acceleration, here's where I see things. So cloud services will continue to expand. It's a great moneymaker for the cloud providers, cloud vendors. It's a very flexible model. It will continue follow because that's where the economics are. Local and personal storage, I think, will remain for a foreseeable future. But I think more and more it will become merely a cache to what's on the cloud. So it will not be anymore. Today, mostly, local offices have storage, and that's their master, and they put just bits and pieces on the cloud. I think the transition is going to be that the local storage in the office will become more of a cache to what's on the cloud, and the cloud will be the master of all the data. The throughput, well, this is something we've seen over 10 years. The connection speeds to residential and businesses around the world has been just steadily going up. It's not going up as fast as I would hope, but it's definitely an improvement, and it's moving up towards that direction. So once again, as soon as we're moving, the bandwidth, your throughput or the bandwidth to end users or nodes goes up, then your gravity drops. And the need for the fast file transfers will continue because as we're waiting for the faster throughput, and we're waiting for cloud services to pick up, all of this will continue. But so this is all it's all a process. It's a growing process. It's probably not as fast because the bottleneck here on the growth of all of this, I think, would be the connectivity and throughput to every house and every business around the world. So this is where I see things. thank you very much. If you have any questions.